Hi everyone, Greg here. So I had a request from a viewer to do a video on strtok and maybe write my own to show how it works inside. So that sounds pretty good. Let's have a look at that. Okay, so I would like to start with a discussion of how you would normally use strtok. So we have here our example string. This is a test. We're going to use strtok on this string. Tok here stands for token. So the whole point of strtok is to split up the string into tokens. So the first variable is the string, and then the second one is where do you want the string to be split. So here I just chosen the space. So when you split along the spaces, you basically split it up into different words. The first token is returned. When you reach the last token, null will be returned. So we go while token, reprint the token. You pass on the string only once, and after that you just pass on null. And so in this loop we get the token until the last one, then we'll have null. So let me just compile that and see what we get. And then sure enough, you see that it splits it up along the words. So one thing to note is that this will actually modify the string. So basically there where there is this space, it will replace it with a null. So you end up with those null terminated strings. So put a null here and a null here and so on. So if I do a printf of the original string and I recompile that, you see that sure enough, this string has been modified. Okay, so I think this is a good opportunity for a quick review on variables and pointers and arrays and strings and the like. So imagine that I declare a variable, so I have int I equals 0, let's say. What does that really mean? That means I'm going to have an area in the memory. It's going to be 4 bytes long. I will refer to it as being I, and it's going to have value 0. Right, so all those 4 bytes will be filled in with zeros. This area will have an address. Typically, this is represented by a hexadecimal number. Once that we turn the code into an executable, those variable names will disappear and they will be replaced with those addresses. So those names, like I, they're really there just for our convenience. As humans, we deal better with those names than we do with addresses, but ultimately it's the addresses that matter. So that's an ordinary variable. Now, what about a pointer? I could have int asterisk p equals 0. What that means is I have, again, an area in memory. So if we have, let's say a 32-bit computer, it's going to be 4 bytes again. And because I've initialized it to 0, that's the value that's going to be in there. This will have its own address, right? Let's say address DEF. These are obviously not real addresses. And so I initialize pointer P to 0. Now, the kernel guarantees that there's never anything at address 0. So when an address is 0, that's just a placeholder for saying this address is not really filled in. Okay? Now, what I can do is I can say P equals and then the address of I, right? What that means then is that this area in memory that we refer to as P, and again has address DEF, will now have value. The value it will have will be the address of I. Okay, the ampersand means take the address of. So P is now, it has the value, the address of I. So in here you will see ABC. So now, what if I do asterisk P equals 5, let's say? Well, the asterisk here Okay, the first asterisk we saw is really just a way of saying this variable will be a pointer. It's a bit confusing because those two asterisks actually mean something related but different. The first asterisk means this is going to be a pointer. The second asterisk means we have an address there, P is the address, dereference the address. And dereference basically means go to the address, right? So dereference P and set the value to 5. Well, if I do that, then I basically will have value 5 now, right? Because P had the address of I, and then we followed that address and gave that the value 5. Okay, if I do P equals 5, then basically that ABC will be replaced with 5. And since that's a pointer, that's really not a meaningful thing to do here, right? Okay, now one place where you may have come across the ampersand is with the scanf. Right? With the scanf, you might say something like, "Oh, read an integer from the terminal." So ask the user to type in a terminal, and then put the value in some variable. And where are we going to put that? We're going to put it in I. Now, why do you give the address? Because when you have a function in C, you have basically two ways of passing on the variables, by value and by reference. Okay? So, if I have something like this, so this would be the prototype of my function. Void would be the output, and then int n is the input. Here, n is passed on by value. So what that means is that inside of the foo function, I can take n and I can do whatever the hell I want with it. I can set it to 3, let's say. Once that I'm done with this function, what will be the value of n in the code immediately following the call of that function? It's going to be whatever it was before. Okay, so if the value was 5, n will still be equal to 5. Now, within foo, I set it to 3, but the n that I have inside that function is a copy of n, so I can change the value there. It will be 3 for the duration of the execution of that function, but once that function is finished, we go back to whatever n was before, which is 5 in this case, and as the code continues, n will be equal to 5. Right? So that's when you pass on a variable by a value, but you can pass it on by reference. So by reference, now I have the same function foo, but now this time I have the asterisk meaning this is going to be a pointer. And then how do I call that function? Well, I'm going to do foo, and then I'm going to do the ampersand of n, right? Because now what I'm doing is I'm passing on the address, right? I'm passing on the address of n. This is passing by reference. Okay, and now within the body of the function, what I need to do is I will do asterisk n equals 3. Right? That means n now has the address. Asterisk means go to that address, right? And then set the value to 3. Right? So now I've actually changed the value of n as it was when I called the function. So now if I continue with the code after the execution of this function foo, then the value of n will be 3. Okay, so that's passing on by value and by reference. So for the scanf, I have to pass on by reference because I have to basically make it clear to scanf where is the address where I want you to put in the value. Okay, I hope that makes sense. So now those are variables and pointers Now we have arrays. Now what are arrays? Well, arrays are basically, they have a type. So like I could say an integer array. So I can call this int r5. Okay. What this is going to be, what this is going to do is it's going to give me an array of 5 integers. And each integer being 4 bytes, so that will be 20 bytes. The important thing to realize here is that we're talking about contiguous memory. Okay, contiguous memory means I'm going to have an address there, and that address is going to be, let's say, 123. And then the address of the next element is going to be that address plus 4. 4 because an integer is 4 bytes, right? So that address plus 4, right? Also important to realize is that the name of the array, R in this case, is a pointer to the first element. Okay, so R is really pointing to the array. So what really happens when you do R2, let's say, equals 3, what's going to happen when you do that? And remember, you number it from 0. Well, the third element will be set to 3. The way that happens internally is that the compiler takes the name of the array, this is an address, and then it will add 2, but because those are integers, it's really going to be 2 times 4 bytes. So it's going to take the address that the array is pointing to, it's going to add 8 bytes, and then that's what it's going to use as the address, and this is the location where it's going to change the value, and that will be set to 3. Okay, so when I do R0 is 5, it takes again the address, it adds 0 times 4, which of course is going to be the same as the address of the first element, and then it will set that to 5. So what I could theoretically do is I could write this, and that would have the same effect as that previous statement, right? It's basically the address R, the asterisk mean follow the address, whatever is at that address, set it to value 5. Okay, so what I could do now is I could create a pointer, and I could say that pointer equals R. Right. Then I do P plus equals 1. What that is going to do, in the first instance, P is going to point to the first element of that address. Then I add 1, so it's going to point to the next element in the array. Right? Now, even though it says plus 1, the compiler will say, well, okay, it's plus 1, but it's an integer type. Integers are 4 bytes. So it will give you that for free. It's going to really move it by 4 bytes, even though you set 1. And now what I can do is I can do asterisk P equals 8. And so that second element will now be set to 8. Right? So that is for arrays. Okay, so now when we look at strings, what are strings? Well, strings are really arrays, but they are of the type character, and so they contain text, and they end in a null character. So if I have something like this, what is that going to do? It's going to create an array of 5 bytes, and this time it's going to be 5 bytes because a car data type is 1 byte, so now this is going to be actually 5 bytes. And actually what I could do is I could initialize this to ABC, and so it's going to have the value ABC and then that null character, and then I'm going to have an extra byte there that I'm not actually using. Now in C you cannot normally initialize strings in this way. You have to use maybe string copy or something like that if you want to put the value of, basically if you want to fill up a string with a particular value. The only exception is, so you can't write this, for instance. That is not going to work. And the reason this is not going to work is because str really stands for the address of the array. So you're basically saying here that the address of the array should be ABC. That doesn't make any sense. So this is not going to work. This is not correct C. The only exception is when you declare the string, then you can, on the same line, in the same statement, you can initialize it in this way. Only then is that going to work. Okay, and string copy is actually not a good function to use, but I don't want to talk about that now. That's a whole other story for another day, but that's only an example to make the point. Okay, so another point is that when you declare an array, the name of that array is a pointer to the first element. This name is going to be a constant, right? So one thing I cannot do is I cannot do r plus equal 1. I cannot loop through the array like this. That's not going to work. That is not going to work. But what I can do is, if it's in a function, then I can actually increment that pointer. So because I've not used that name here to declare an array, this is not a constant. So now I can actually use this. So now I can actually increment this pointer, and it's going to point to the next element in the array. So that means that if I want to loop through an array, I basically have two choices. I can increment the index of the array, or I can increment the pointer. And these are two equivalent ways of looping through an array. Okay, so here you see an example where in each case I just set every element to 0. And this is not an efficient way of setting the whole array to 0. In fact, if I want to do that, it's much better for me to use memset, right? This is probably the most efficient way of setting the whole array to 0. But all three of those approaches are going to work, and all three of those approaches are going to get the job done. And all three of those are correct C. So another thing that is important in order to understand how strtok works is the concept of the static variable. So the keyword static has different meanings. It has 3 different meanings depending on the context. I'm just going to focus on a static variable here. What static means is that the value of the variable does persist across multiple calls of the function, right? So if you take the first example of foo, you have integer n, it's initialized to 0, you add 1, now the value is 1. Once that the function is finished, and then you call the function again later, n will be initialized to 0, you add 1, it will be 1 again, and that will be true every single time you run the function. With a static variable, you run the function the first time, n equals 0, you add 1, it will be 1, and then that value will remain 1. So the function finishes, then you call the function again, the value of n is still 1, and then you add 1, so now it is 2, and so on. Across multiple calls of the function, the value of that variable will persist. Okay, so that's a static variable. So I don't actually recommend you use static variables. In my experience, they are very prone to cause bugs. So they do exist in the C language. It is an option, but I would advise against it. Okay, so here now is my version of strtok. If we look at the main function, this is almost the same. This is almost the same as the one you have seen here with the first example. There's only 2 differences. Number 1, I've changed the name of the function, right? But number 2 is I've used a character here instead of a string. The reason I've done that is because it's easier with a character. I'll do it again with a string in a minute, but this is going to be like a stepping stone function. First, let's understand the easier way of doing it, and then we'll move on to the full way of doing it. So here is my strtok. I've used a static buffer. Now, I've just said that I don't recommend its use. in this case, I'm just trying to duplicate the behavior of strtok. And so it's very clear that this is what the function is using, right? What the official function is using. Because you have the string passed on the first time, and then it's no longer passed on the second time. So the only way it can still know what the string is if it uses a static variable. So you have to use a static pointer here because of the way that they designed this function. So buffer equals null, right? Then if there's nothing in the buffer, then buffer equals the string that is passed on, right? So the first time that you call this function, obviously buffer will be null. That's what we initialize it as. The second time you call the function, buffer will already contain str. Okay? Then we look if the first element in the buffer, right? Because buffer is a pointer, so we just dereference it. We look at the first element. We look if there is something in there. Now, if there is not, that means either we had an empty string the whole time, or it could be that we went through the string and now we got to the end of the string. Either way, if there's nothing in the first element, we just return null. Then we have a pointer to the beginning of our token, and we just go through the buffer. So we increment the pointer to the buffer. We just loop through the buffer, and we stop when either we reach the null character, which would be the end of the string, or when we reach a character which is the same as C. So that would be our space here. If we meet the space, then we stop. So for either of those two reasons, we stop. So if we reach the end of the buffer, there's nothing left to be done. So this if will fail. If there is something in the buffer, that something has to be the C, right? The C character. So at that point, we change the buffer to, well, we could make this null. It's the same thing, right? But it's basically, you put a 0 there. So you basically cut up the string into tokens, so that C becomes the null character. And then you move the pointer forward, because that pointer is now pointing at that null character. The next time we call the function, we need to be just behind that token to basically be pointing at the start of the next token, right? And then we return token. So that is basically where we started here. Before we looped through the buffer, we return a pointer to the start of that token, right? Okay, so shall we run this? What do I have here now? So I'm just gonna do. Okay, and what do you see? You see this works fine, and this works in exactly the same way that strtok was working. Okay, so now this function is the real deal, and you see that C is now no longer a character, it is a string. So that's a character pointer, because of course the name of the string is a pointer to the first element of the string. So, and what I have here in the main is I changed the example, right? Because previously we just had a space there, but what we need to demonstrate, we can split the string across an entire string rather than just across a single character like a space. So I've changed the example. This is a message, stop. I'm putting that word at the end of each sentence, stop, and so on. Right, so it should split across. In fact, let me just demonstrate that it does. So the word stop is gone, and instead the string is split there, right? Okay. So how did I achieve that? You see, this is more complicated now, right? Here you will recognize a loop that is very similar to the one we had earlier, but now I have the asterisk there. So what I'm doing is I'm going through buffer. in fact, yeah. Let me change that to token, right? I changed those names. Token is just makes it more clear, right? So basically, I'm going through the buffer. I check, is there no character? If so, we're at the end of the buffer. Or is the element at that point of the buffer, is it the same as the first element of the string C? And as long as that's true, we're going one further. So now when I stop here, either I got to the end of the buffer or the buffer is the same as the first character as C. So now I need to check what is the same as the rest of C, right? So I have len here is the length of C, right? So while I is smaller than len, and I just check whether the rest of the buffer is the same as C. So I have to check that because, you know, imagine I have a single capital S here that is the same as the first letter of stop. Now I have to check that the rest of it is also the same, right? So that's what I'm doing here. When I get through that, I check if I is the same as len, because, you know, I need to find out why did we stop looping here. Did we get all the way through to the end, or at some point was that condition no longer true, and did the buffer start to be different from the string C? So if we did get all the way to the end, that means that we indeed encountered the word stop there. So then we put a null character there, and we move the buffer forward. So that's basically the same thing we did here. We put a null character, we move the buffer forward, but here C was just a character, so we moved it by 1. Okay. Here C is a string, so we have to move it by the entire length of the string. If we didn't make it all the way through, then we increase buffer by just 1. Okay. So what if I have? So I'm going through the loop here. I notice, oh, I stop here because that's my capital S, same as stop. I look at the rest, and then I realize, oh, this is not the same as stop. So then when I check here, I will not have been the same as the length. So this is going to fail. Instead, I'm going to go here. And instead of buffer pointing here, no, buffer needs to point here to continue comparing the rest of the string past that first S. Right? So that's what that does. And so you have this bigger loop, and it does while we haven't reached the end of the string, and I is not the same as len. Okay, so when I is the same as len, that means we have found a section of the buffer where the buffer is fully the same as the string C across its entire length. So as long as we haven't reached the end of the buffer, and as long as I is not the same as len, we need to keep going through this loop, this bigger loop. Okay. So now what if I have this capital S and then STO, right? Now that's, you might say that's not a reasonable situation, but my function has to work all of the time, right? So what's going to happen if I have a situation like this, it's going to stop. It's going to go through this loop. It's going to stop at the first S. It's going to see if the rest is the same. It's going to decide it's not. It's going to move 1 forward. So that's going to get here. Then it go through the loop again. And then it will decide, oh, that's the same character again. That's the same starting character again. Then it will go here. And now it go a little bit further, but then it will stop again. It will see, is I equal to len? No, it's not. Okay, and now it's gonna again move 1 forward again, so it's gonna be T. This time it will be on the T. and then we'll go through the loop again, and it will say, okay, is it the same as the first character? Oh no, it's not. So now it's going to go all the way here. Okay, next time that this loop stops, it's going to be all the way here. Then it will see, is the rest of C the same? Or the rest of the buffer the same as C? This time, yes, it will. So now this loop will stop because I will no longer be smaller than len. Now this will succeed. So then this first S will be set to 0. It will be a null character. And then buffer will jump to the entire length. So buffer will be set to here. We'll be pointing at this I. Right? And then now that I is equal to len, this loop here will fail, and then it will return token. What is token? Well, that is the buffer. Token is basically there where we started checking the buffer, so token will be pointing at here still. Okay. When we run the function again, token will be pointing here. Right? So hopefully that makes sense. This is more complex now, as you can tell, but it does work. So if I rerun that, you see that indeed it's not confused by this nearly stop here. Right? Okay, so during the editing I realized I hadn't quite finished the job, so this is just a little bit of finishing touches, if you like. So if you take the normal strtok and if you make this null, then this will actually cause a segmentation fault when you run it. Now I did not duplicate that behavior because I thought that was just silly, and you know, I mean, there's no point in trying to duplicate too meticulously a behavior that I personally think is not a very good design in the first place. So I'm not going to do that particular thing. But the second time you call strtok, the string is null. Now what if you don't do that? What if you do this? What would happen is that strtok would always go back to the beginning of the string. Right? So basically the first time it realizes, okay, this is the first token, it puts the null character here. It will set its pointer here, and then you call strtok again with that string. It will go back to the beginning of the string and check what the first token is. It will reach the end of the string, and because you keep calling it in this loop, you keep calling it with that string, it will just always return the first token, and it's going to be stuck in this infinite loop. Okay, so again, you can question the design here, but anyway, that is how they designed it. So let's just see how I did this here. So if not C, I just return null again. That's not really in line with the normal strtok, but I'm just going to do it that way. And then if string, so if this is not null, in other words, then buffer equals the string. Else, so if string is null, then we just check if the buffer is null. So basically, if we've reached the end of the buffer, right? So if string is null, then we just check the buffer. So maybe we reached a null character, or maybe maybe we never initialized buffer in the first place, right? If this was null the very first time that it was called, then buffer would still be set to null here. So either way, we return null. Okay, so this will, if not exactly, then at least closely match the behavior of strtok. And I'm really done with this now. This is the my finished version of strtok. It's not exactly the same thing, but it's very close. Okay. Alright, so this is it. Thank you for watching. I hope you enjoyed this one. Please give me a like and a subscribe. At the moment of recording, we have 475 subscribers, so that's really awesome, and thank you to everyone who has subscribed already. We are nearly at the milestone of 512 subscribers, so I'll be doing another ducks video when we get to that point. And if you enjoyed this video, YouTube will have some suggestions on the screen as to what you might be watching next. See you in the next one.